Let's take a look at a couple exercises here that involve the factor theorem. Use the factor theorem to find all real zeros of the polynomial with one factor given. The first problem we're going to look at is the function f of x equals x cubed minus 13x minus 12 with the given factor being x plus 1. Here we're using f of x notation for a polynomial. Sometimes we use p of x, sometimes f of x. It really doesn't matter either way, works fine. And I know when these are instructions taken right out of the textbook, and when I first read these I thought, well, what does the factor theorem have to do with zeros of a polynomial? And it occurred to me that, really we could just reword our factor theorem. This was my original card about the factor theorem. X minus k is a factor of p of x if and only if p of k equals 0. Well, when we say p of k equals 0, that means exactly the same thing as saying k is a 0 of p of x. K is where an x-intercept would occur right on a graph. So x minus k is a factor of p of x if and only if k is a 0 of p of x is an equivalent statement of the factor theorem. So you don't need both. They both say the same thing, but I thought maybe showing you this alternate wording helps you see the connection to zeros. So what we want to do here is we want to find all the zeros of this polynomial, and again, zeros are going to correspond to factors. That's what the factor theorem is all about. So if we can factor this completely, we're going to be able to see what those zeros are. Maybe that's the simplest way to put it. So now x plus 1 is a given factor. So that means we know that f of negative 1 is equal to 0. The corresponding 0, or the k value, is negative 1. When we see those factors given, you got to remember the sign's going to be different, because the value of the 0 is the number you could plug in here to get 0. So when you plug in negative 1 plus 1 is 0. So we're going to use synthetic division here. To divide by x plus 1. So I'm going to write down the coefficients of my polynomial. So 1x cubed. There's no x squared term, so I have to write 0. Then negative 13x, negative 12. And the number that I write out in front now is going to be, it's negative 1. It's the value of the 0. It's not, plus 1 again. This is a case where really this x plus 1 stands for x minus a negative 1. And now let's go ahead and go through the process. So bring down the 1, multiply, I get negative 1, add, negative 1, multiply, I get 1, add these together, I get negative 12, multiply, I get positive 12, add these together, I get 0, and I should get that, get 0, and because that remainder is equal to f of negative 1, and I know I'm supposed to get 0 in this problem. What's going to be helpful for us here is the quotient. So these are the coefficients of the quotient. We have to start on the right, constant, then go first power, second power. So this is x squared minus x minus 12. And so what do we have here? We have this original function f of x is x cubed minus 13x minus 12. And we know that x plus 1 is a factor. And because we also, it's a factor and we have a 0, we know this divisor times the quotient is f of x, because the remainder on division would be just plus 0, right? So we don't have any remainder to add on. And so, in a sense, we've started factoring this polynomial, right? We factored into x plus 1 times x squared minus x minus 12. Now, if we can keep factoring will help us find the remaining zeros. Keep factoring to find the remaining zeros. And you actually can use your old-fashioned knowledge about factoring trinomials here to finish this up. I wouldn't do any more synthetic division. I would just write this as x plus 1 times, I'm going to try to factor this trinomial by hand, x and an x. Negative third term means I need two different signs. I want to get a minus x in the middle. What about plus 3 minus 4? That checks out. We got it factored. So here we were able to kind of get to this point of the problem by breaking down that quadratic using good old-fashioned factoring. And so now we see that f has 3 factors, and there are 3 factors. And so there are 3 real zeros. The real zeros of f are, there's going to be 1 for each factor. So the x plus 1 factor corresponds to the real zero of negative 1. There's an x-intercept on that graph at negative 1. The x plus 3 factor corresponds to a real zero of negative 3. And the x minus 4 factor corresponds to a real zero of 4. You can write those in any order you want. There, we got the real zeros of that polynomial. Let's see, we can get, oh yeah, we can get everything on there. There we go. All right, let's do one more. And it's same instructions. And here, the polynomial I'm working with is x cubed minus 5x squared plus 5x plus 3. So it looks very similar to what we just did. And we're given the factor x minus 3. So we know that if this is a given factor, then by the factor theorem, we know f of positive 3 is 0. So we would say 3 is a 0 of the polynomial. So I'm going to apply synthetic division again, and I'll take these coefficients, 1, negative 5, 5, 3. I don't have to write a 0 this time. I'm going to write a positive 3 here, because this, the sign on this number always matches up the sign there. It's opposite the sign of the factor. This is the number that would make the factor equal to 0. So let's carry out the synthetic division. Bring down to 1. 3 times 1 is 3. Add these together, I get negative 2. Multiply, I got negative 6. Add these, negative 1. Multiply, I got negative 3. Add these, I get 0. So there's my remainder, which is equal to f of 3. And we knew that. We should have got that. We want to observe what our quotient is, constant, first term, second term. So I got x squared minus 2x minus 1. So my polynomial here, f of x, which was x cubed minus 5x squared plus 5x plus 3, we now know factors into one factor being x minus 3. And then we will have this x squared minus 2x minus 1. Now to find any further real zeros, we're going to try to break down that x squared minus 2x minus 1. If I try factoring here, and be careful with this one, it's you know, it's because you see 1 there, you see 1 and 1, and then it's a little bit tempting to write minus and minus to get the minus 2x, but that doesn't really work because we got a negative 1 third term. Negative 1 times negative 1 is positive 1. And I can't make one of these plus because that messes up the middle term. This is not factorable. And at least in this way. But we can still find more zeros by taking x squared minus 2x minus 1 and setting it equal to 0 and applying the quadratic formula. So a 0 is any number you can plug in for x to get the function equal to 0. If it makes that x squared minus 2x minus 1 equal to 0, times the other factor will make the whole function equal to 0. So there are more zeros here. And let's see, we got a equals 1, b equals negative 2, c equals negative 1. So I'm going to plug into the quadratic formula. X equals negative a negative 2 plus or minus the square root of negative 2 squared minus 4 times 1 times negative 1 is c all over 2a. So x is equal to 2 plus or minus the square root of 4 plus 4 over 2. So x equals 2 plus or minus the square root of 8 over 2. I can simplify that square root, right, because it's 4 times 2. So x is equal to 2 plus or minus 2 radical 2 over 2. And I'm going through the details because I know students make a lot of mistakes canceling here. We can only cancel 2's up above if we can factor out a 2 entirely from the numerator. If it helps you to take the positive and negative roots aside separately, that's fine, but you can factor it this way also. We'd have 1 plus or minus square root of 2 all over 2, and then these 2's cancel. So x equals 1 plus or minus square root of 2. So let's see, what can we say here? So in our problem, f of x has real zeros. There are actually 3 of them. So we have 3 was the first one. Don't forget the first one we were given. 1 plus the square root of 2. Also 1 minus the square root of 2. And it was a little tricky finding the second and third. And there is a connection to factors. We can't factor by hand with integers, but if you allow factoring with square roots, there is a way to write this function with these zeros that involve square roots. So just don't freak out about it now, but f of x could be written as x minus 3 x minus 1 plus square root of 2 times x minus 1 minus the square root of 2. Sorry, I couldn't fit that on one line. So that all goes together. And again, we're going to talk more about this later. It's just we've never seen funny looking factors like that before, I don't think. But if you multiplied that out, you would get that quadratic that we saw along the way. So there's our answer to part B. And I'm just covering up some of that square root simplification. We get 3 real zeros for that original polynomial.